In this third lecture from Chapter 5, we will study another useful discrete probability distribution, the Poisson. Poisson distribution is useful in estimating the number of occurrences over a specified interval of time or area or distance. The random variables are discrete whole numbers. Again, think of counting things. But with only two possible outcomes, the Poisson variable may assume an infinite sequence of values. The most familiar examples would involve time. For example, the number of cars arriving at a toll booth in an hour, or the number of calls to a call center in 10 minutes. The key assumptions behind the Poisson distribution are that the probability of occurrences are the same for any two intervals of equal length, and the probability is independent in one interval from any other interval. As with the binomial, the Poisson distribution can be represented mathematically. Note that there are only two required variables: mu, the mean number of occurrences in an interval based on experience, and the question of interest, x, for a different number of occurrences in that interval. Also included in this formula is the constant e. Thinking of the toll booth example, there is no upper limit. But practically speaking, if x is so large, the probability will eventually approach zero. For a practical example, consider a hospital emergency room. We are given a mean number of variables based on history or experience. And we want to know the probability of a different number arriving in an interval. The first step is to convert our mean into the same units of interval as the question we are asking about x. So our original mean of 6 per hour becomes 3 per half hour. So now we want to know what is the probability of 4 arrivals in a half an hour. Using the formula, we come up with the answer of 0.168. As with other probability distributions, we can graph the Poisson. Its shape is unique and predicted by that mathematical formula. We are fortunate, though, again, that statisticians have calculated Poisson probabilities for a wide range of the mean mu and the x values and put them in a table for our convenience. Excel has a simple function, Poisson.dist, to calculate this for us as well. And as with other probability distributions, we may need the mean and the variance and the standard deviation. In this case, the mean is given in the definition of the problem, and the variance is equal to the mean.